So, why do ceramics and silicon nitride outperform coated carbide?
Reason number 1. Because of its higher hot hardness. Its ability to stay hard at much higher temperatures than carbide or cermets. This translates into all kinds of advantages. The tool can be run at much higher speeds. The edge will stay sharper for longer periods of time. This means increased tool life and a better surface finish. Also, ceramics resist plastic deformation. Black ceramic, white ceramic, and silicon nitride retain much more of their hardness at higher temperatures than coated carbide, as you can see from this graph. Here, we see a difference in strength, or shock resistance, as temperature rises on ceramic, cermet, and coated carbide. Reason number 2, because of its cleaner cuts. There is no built-up edge, as there is with tungsten carbide. Built-up edge is due to the carbide chemically reacting with the workpiece. Ceramic and silicon nitride are very inert. They do not chemically react with the workpiece at all. Reason number 3, heat transfer performance. With ceramic and silicon nitride, almost 100% of the heat generated by the operation goes off in the chip, meaning hardly any heat goes into the insert. This means longer tool life, and the cutting edge is not breaking down. Also, the additional heat in the chip helps to break the chip. With tungsten carbide, about 80% of the heat goes off in the chip. This means that 20% stays in the insert, contributing to edge breakdown.
Now that you know a little bit more about us and our products, let's get down to applications.
Iron roughing. In just about any iron roughing application, whether it's ductile, malleable, gray, cast, you name it, people generally use a coated carbide for roughing. They're losing money and they're wasting cycle time. Silicon nitride can run faster. It will give you longer tool life. You can operate it at higher speeds. And it will cut cleaner than a coated carbide. Romay Corporation has more grades of silicon nitride than any manufacturer. In fact, we're one of the few manufacturers that has dimpled inserts.
Iron finishing. For all iron finishing applications, you have 3 choices. Choice number 1, use a silicon nitride insert. Silicon nitride will cut cleaner, last longer, and give a better surface finish than any coated carbide on the market today. Choice number 2, use a black ceramic. That's Romay grade CC20. The black ceramic will offer all the same benefits as a silicon nitride, and yet it costs even less. Choice number 3, use a white ceramic, Romay grade CC10. The CC10 will last even longer than the CC20, and it's comparably priced. All of these choices are excellent for any iron finishing application.
Steel finishing. For regular steel operations, most people, again, use a coated carbide for finishing applications. The same thing applies here. They're losing cycle time, they're losing money. Try a black ceramic. It will run faster, it will produce a superior surface finish, and it will last a lot longer. Once you get the black ceramic working, try the white ceramic, because where that works, it will be even superior to the black ceramic. Hard steel, and by that I mean Rockwell C58 or above in hardness. A lot of people use CBN, that's expensive. Some people use coated carbide, but it just doesn't give the tool life. In almost any finishing or semi-finishing application, you can use our black ceramic for hard metal, the CC30, or our gold-coated black ceramic for hard metal, the CC30C. Again, compared to coated carbide, these inserts run much faster, they last longer, and they give a far superior surface finish. In fact, in several operations where people were using a carbide to finish with, and then maybe they had to grind it afterwards to get a certain surface finish, when they've used our CC30 or CC30C, we can eliminate the grinding operation.
Aerospace metals, such as Inconel, Hastelloy, Waspaloy, and Romay. For these materials, you can use our specially designed CC5477. Powdered metals. Now for these materials, you can use our hard metal black ceramic. That's grade CC30. Also, our gold-coated hard metal black ceramic, CC30C. These grades work very well, especially in finishing of powdered metals.
What industries use black and white ceramics and silicon nitride?
Most black and white ceramics and silicon nitride come in negative or neutral rakes. This allows you to double the number of cutting edges per insert. That means that the tool cost is reduced by 50%. Now most of you might say, well, but we need the positive rake because we have a certain surface finish requirement. But remember, the black and the white ceramic and the silicon nitride will give you a superior surface finish. So you may not need the positive rake. But for those of you that do need the positive rake, maybe for other reasons, both the black and white ceramic and the silicon nitride come in positive rake inserts also. Usually the customer has already chosen the shape of the insert. But if not, always choose the strongest edged insert. Take a look at this graph and we'll show you what that means.
Let's take a moment to talk about edge preparation. This is a very critical subject. Edge preparation can spell the difference between success and failure. If we're testing against a competitor's grade, we want to have the exact same edge prep that they have. So it can be our grade versus their grade, not our edge prep versus theirs.